right, next thing we're going to look at from section 2.1 is what's called interpolation and extrapolation, which, again, those words sometimes I struggle with pronouncing, so bear with me. All right, interpolation is the process of estimating. So this is an estimating process. This is kind of what statistics is, a little bit. Values between known data points. So suppose that, again, I know from 2000 to 2010, but I want to know about 2008. And so what we do is we take the average rate of change from between the two known values. So the two known values would be from 2000 to 2010. All right, we'd find that average rate of change, And then we'd use that to find the 2008. And so what we do is we take our starting value, the one in 2000, and we'd add the average rate of change 8 times, because this would be sort of the per year, right? Per year, this is how fast it grows. And so 2008 is 8 years after my starting point. And so every year for those 8 years, we should have added whatever that added rate change. So 8 times the average rate of change, right? Because that's how many times it would go. All right, so that's interpolation when we know 2 points. All right, extrapolation, we use average rate of change again. I don't know why I'm erasing it. I guess I just felt like it. We use but the difference between it is this is interpolation typically is a little better because it's between two known points. Extrapolation is estimating a value beyond what you're given. So suppose the last data point was the 2010. All right, that was your last data entry. Well, we want to know, what about 2015? All right, 2015 is beyond my last data point. And so again, you use the average rate of change from the end two values. All right, so suppose it was 2005 to 2010. All right, those are the last two data points we know. Well, we find the average rate of change from 2005 to 2010. We use that to estimate what it would be in 2015. And 2015 would be 5 years after 2010. And so we would add this 5 times. We take our average rate of change from, alright, I said 2005 to 2015. I meant 2005 to 2010. We take the average rate of change from 2005 to 2010. We take the last data entry, which was 2010, and we add that average rate of change to the last value. So it's the end value in this case that we add it to, right? Whereas interpolation, we add it to the starting value. So again, that's the difference between the two. All right, so we're just going to look at an example of those. All right, so example 1. Suppose that we know, again, it's the same salaries we had in the previous example. So the salaries from 1990 to 2010. Use the interpolation to estimate the salary in 1998. So 1998, we got to find what two values is it between. 1998 is between 1990 and 1995. So we're going to use the average rate of change from 1990 to 1995, which we found that on the previous page. Wait, did we find that on the previous page? Oh, no, we just found the percent change. We didn't find the average rate of change. Oh, and I picked the wrong year, so no, we didn't find it. Let's try that again. 1998 would be between, 1995, right, between 1995 to 2000. So we did not find that previously, so we'll have to find the average rate of change for this one. All right. It's between 1995 and 1998, lands between 1995 and 2000. All right, so first thing I have to do is find the average rate of change between the 2 years that I'm interested in. So 1995 to 2000, so we take our 65,000 from 2000, subtract our 63,500, divided by, again, average rate of change is the change in salary over the change in time. So time was 2000 minus 1995, 5 years. So up top we take the subtraction, so that subtracts to 2,400 divided by 5 years, so it comes out to per year. All right, so on average, the salary grew by $480 per year between 90. So it didn't grow by much between 95 and 2000 were slow growth years. It didn't grow, and actually, if you look at that, it didn't grow by too much, right? It only grew by a couple of thousand between those years. All right, so $480 per year is what the salary grew by between 1995 and 2000. All right, so we start with the 1995 year. All right, so that's the starting salary. The starting salary was $63,500. We get to add $480 per year. So when we go from 1998 to 1995, right, that would be 3 years. All right, so 3 years we get to add $480. All right, so we take our base salary, $63,500, and add to it 3 times the additional amount we get every year. So 3 times the 480. Right? That's how much we would estimate the salary would be in 1998. Right? So when you take those values and add them together, it comes out to $64,940 would be the estimated salary in 1995. And again, 1998. 1998 is what we're estimating. And kind of make number sense, too. You should always kind of check to make sure your answer makes sense, right? 95, it was 63,000. 65, in 2000, it was 65. And so 64,000 is somewhere between those two values, and that should be right? It should be between the two values that I used, all right? So again, that's sort of a check step. All right, so interpolation is when we use the average rate of change for a value between two known values. Extrapolation is when we estimate something after our last data point. So, right, our last data point was in 2010. So we want to estimate 2012, which is after, right? That's after 2010, which was our last data point. And so, again, we're still going to use the average rate of change. We're going to use the average rate of change for the end two values. All right, so from 2005 to 2010. All right, so average rate of change. So we take the 88,000 from 2010, 250, subtract away the 75. One too many zeros. Divided by our years. And again, it's 5 years, but I'm going to write it out so you can see it. All right, it grows by 5 years. All right, so up top, I take the subtraction, the change in the salary from 2005 to 2010. The change in the salary from 2005 to 2010 was $13,150 divided by the 5 years. All right, so you take the $13,150, comes out to be $2,630 per year. So actually, between those years, the salary grew by a lot more than it did between 95 and 2000. All right, so we're estimating 2012, which would be 2 years after 2010. So this is on average how much it grew. And so we're going to add 2 of those to the 2010 year. So we're going to take the 2010 was 88,250. We're going to add 2 of those because it's 2 years after that. 2,000 because we get to add 2 of those because it's 1 per year. So for 2 years we get to add those amounts. So 2 times the 2,630 comes out to be 93,510 was what we would estimate the salary in 2012 would be. All right, based on our information. All right, let's do a second example. All right, the population of Alaska has been given by the year below. So again, year is always the independent, time is always the independent, population is the dependent, right? How big the population is depends on what year we look at. All right, so population depends on what year we're in. All right, the year, earlier years, in this case, looks like there are fewer numbers than later years. All right, so we've got our Alaskan population. We're going to complete the table, so we're going to kind of put it all together in this one. So we're going to find the change in the population, the percent change, average rate of change, then we're going to do an interpolation and an extrapolation. So this is sort of putting it all together in this example. All right, so first, we'll find the change in population. So we're going to find the change in population between each data point. So we're going to go 98 to 99 first. And so that would be taking our 99, so 5,042 minus the 40152. And so that comes out to be 148190 would be the change in population from 1998 to 1990. Then you do 90 to 2000, so 626,932 minus 550042, and so that comes out to be 76890 would be the change in population. And then the last 2 years between 2000 and 2010, so 10,03232 minus 626,932. All right, make sure I wrote it down right. Yes, I did. All right, that comes out to be 83,300. All right, so there's the exact change. Now remember, percent change is the change in population divided by the starting year times 1,000. So remember the percent change. So it'd be, and I'm going to use this change because that's the change it's going to do. But you have to remember what you divide by. You divide by the starting year. So the percent change is going to be the change in above, that 148190, divided by the starting year. So we divide by the amount in the starting year, which I wrote that down wrong. So it would be the 401852 times my 1,000%. Keep wanting to say 1,000. 100%. And I'm just going to round to the whole percent. So I'm going to round up to 37%. 37% growth. All right, so between 1980 to 1990, Alaska had a 37% growth rate in their population. All right, from 90 to 2000, so again, same thing. I start with 1990, so I take the number I have for the population change, which is 76890, divide by the 1990, because that's my starting year. So the 1990 was 550042 times my percent. Comes out to be, it should be a smaller percent, right? That's a much smaller number than 98 to 1990, right? And it's actually about half. And the percent's about half. It comes out to be 14% if I round to the whole number. So it had a smaller growth rate between 90 and 2000, only 14%. And then between 2000 and 2010, so same thing. The difference was 83300. We divide by the 2000 year, which would be 626932 times my percent. Comes out to be, oh no, it's less than, so it's only round to the whole, I'm going to round to the whole percent, 13%. All right, so the population grew every year, but the last two sets were much smaller than the first one. It grew by a lot more between 1980 and 1990. It grew by less 1990 to 2000, and it was close to the same, but it's still less than. So every year it grew by a little bit less between the years. All right, so the last part is find the average rate of change. Remember, that's the change in the function divided by the change in the time. The change in the time for all of these is 10, right? The change in the time is 10 years, right? 10 years for each one. 1990 to 1980, 10 years there, and 10 years there. And so for each one of these, we're going to divide by the change in time, which is years. So we're going to take the change in the population and divide by the change in the time. So I'm going to take my 14,8190 and I divide by 10. And I'm going to do that for every single one of these. So all of them are going to be the change in the population divided by 10. And so again, this comes out to 148190 people per year. This is going to be the 76890 divided by 10, right? That's the change in the population over the change in the 10 years. Comes out to 7689 people per year. And then the last one, the 83300 divided by 10 comes out to 8330 people per year. All right, so the average rate of change. All right, so there's change in population, percent change in the population, and average rate of change in the population between each year. We did it between each data set. All right, so the last thing we're going to do on this problem is then we're going to do an example of interpolation and extrapolation. So interpolation we want to predict in 1986, so this time let's make sure I get between the right years. 1986 would be between 1980 and 1990, so I am going to use this average rate of change, right? Because it's between 1980 to 1990. All right, so I'm going to use the average rate of change between 1980 and 1990, so we're going to use the average rate of change, 14,819 people per year. So on average, we added about almost 15,000 people per year between 1980 and 1990. And so we always use our starting years. You use 1980 is where we're starting at. So you use the population started 1980, which was 550042. 86 would be 6 years after 1980, and so we're going to add that to it 6 times. So we're going to take the 550,042 and add that 6 times. So we want 6 of those. So 6 times we're going to add 14,819, and that should estimate the population in 1986. So that comes out to... Oh, and I used the wrong time period. Ah! I looked at the wrong value. I should have gone all the way back up to my table and looked at the right value. Alright, well, this is a good learning lesson, so I'm not going to keep it. Think about changing the video, but I might keep this one just as to show you an example. I used the wrong time, right? The wrong year. Because I didn't go look at my table, I looked at the value. Alright, and some of you might have caught it while you were watching this. Alright, I used 1990 instead of 1980. 1980 was, and the reason why I kind of knew that is because I was looking at the value was coming out way bigger than it should have. It should come out between those 2 years, and it came out greater than those 2 years. I needed to use the 401,852 from 1980, so I start with 401,852, and then I add 6 of those. And again, the reason why I knew it wasn't right, because when I typed the numbers out on my calculator, it came out bigger than the value, and it came out like 63,000, and I go, well, that can't be right, because my 1990 value is 550, and then I realized what I did. All right, so it's always a good idea to kind of make sure at the end of the problem, does the number make sense? And in this case, it didn't make sense, so I went back, and I go, oh, I picked the wrong, and that's really something easy to do. Students do that all the time. They pick the wrong starting value. So it was a good sort of example of this is what can go wrong, so make sure you're careful that you pick the right starting value that you're going to add. So 6 times 14819, and that's going to put us at a much better number, 4,966 people. All right, and it is a number that should be between my 401 and my 550, and it is. All right, so that number makes sense. That number, again, that is the correct value. So 4,900 is the correct number between that one. All right, extrapolation. Let's see if I can get this one right. Predicts the value in 2012. So 2012 is what we want to predict. So again, where you're going to use the last endpoints. The last endpoints are from 2000 and 2010. So use the average rate of change from 2000 to 2010. All right, which was 8,330 people per year. All right, you're going to start with the 2000, so make sure I go get my correct starting values. So start with the, oh no, this time we're going to start with the end values. Again, I was going to do it wrong again. Start with 2010, which was our 710,000. Make sure I write that down right. Start with 2010 because it's the end. So 710232 is what we're going to start with. All right. All right, because the average rate of change was 8,332. 2012 was 2 years after 2010. And so we're going to add 2 of these. So we start with 70232. We add 2 of the 8330s to give us 726,892 people. And again, making sure my number is sort of your check. Alright, that number should make sense. It should be bigger than 2010, but not a whole lot bigger because it's only 2 years later. Alright, so again, that number seems pretty accurate. Had I picked 2000, it would have been wrong because it would have been smaller than 2010. Alright, so it's sort of my check at the end there. Alright, so again, like I said, I'm going to leave it because it's always a good example to show you where things can go wrong and how you kind of let you know about it to make sure, alright, that number makes sense or the number doesn't make sense. It's always a good thing when you're doing math. Does the final answer that I get make sense? If it does, then you're probably in a pretty good place. If it doesn't, kind of go back and rework it. And sometimes the numbers are just weird. So, but these ones are fairly easy to estimate. It should be between the years. And when it's extrapolation, it should be bigger than the last year if we're increasing. All right, we'll stop there. I'll pick up the next examples, the remaining examples in the last video.